Thank you for joining us today on our webinar, A Proven Strategy for Higher Test Coverage with API Testing. My name is Mark Lambert. I'm VP of Products here at Parasoft, and I'm joined by Chris Colosimo, who is our Product Manager for our Functional Test Automation Technologies. And obviously, our product, Parasoft SOA Test, falls into that product portfolio. So today's conversation is all around API testing and how we can help you scale to achieve higher coverage. But API testing fits into a larger test automation strategy. So test automation strategy, to make sure that you are scalable and maintainable, needs to be built on top of the concept of the testing pyramid. I know a lot of folks on today's call are probably familiar with this. This is being exposed very much kind of led by the agile leaders such as Martin Fowler and Michael Cohn. Basically, we're saying establish a broad set of API and unit tests at the lowest level of the testing pyramid, and then kind of minimize, don't eliminate, but minimize the number of end-to-end UI-focused testing activities, both manual and automated. In fact, your ultimate goal here is to ensure that your manual tests are really doing exploratory testing rather than just validating regressions or doing repetitive tasks. And this is really where automation comes in to help you streamline that process. Now, at Parasoft, we do believe that there's a missing layer to this pyramid, which is the deep code analysis to ensure reliability and security. But really, that kind of comes in right at the beginning of the testing process, and we've covered that in other webinars. And in fact, actually, we did one earlier last month about how to choose a static analysis technology, and invite you to kind of check that one out. Now, at Parasoft, we've been doing continuous quality for a little over 32 years, so we have the opportunity to talk to a lot of clients and a lot of people at different stages in their adoption of test automation. And when we talk to folks, it is not uncommon for people to identify with more of an inverted pyramid or an ice cream cone, and with a heavy reliance on UI-centric testing practices. The challenge with this is that while these are quick to define, they're hard to maintain. It's often very difficult to keep pace with the accelerated delivery that's coming from the team. And because those tests are more complex, involving more infrastructure, you end up running into constraints of your test environment, as well as just general delays that those tests take longer to run. If we focus on the other layers of the pyramid, these are much easier to execute. They're quicker, they're easier to control the test environment, but require more technical expertise. And when we talk to organizations about how they are currently looking at within their testing practice, we'll actually see that API testing is actually worse than what a lot of people think about. And actually, this was one of the questions that was posed to you as you registered for today's webinar. So let's take a quick look at those poll results. Now, we can see here that actually almost 50% of our audience didn't answer the question. This kind of indicates to us that either there's a problem with the polling system and people could just skip straight past the question, or folks just don't know what their level of code coverage is. And if I actually focus in and say, okay, let's look at folks that did answer the question and gave us some data, this really does match what we've been seeing in the industry. So the majority of people are expressing that they have less than 20% code coverage, or should I say less than 10 to 20% test coverage against their application at the API level. And this is a real challenge because really API testing and testing at the API level has a lot of advantages to it. So let's talk about those a little bit. So testing at the API level has got several pros. They are more maintainable and certainly more maintainable from an end-to-end test scenario perspective. You're not as you're not at the the mercy of small incremental changes to the UI breaking your functional test flows. they also become a sweet spot for communication between dev and test, because they're actually easier to debug and diagnose and reproduce for the developers. They're closer to the code. They don't have to stand up as much environment. They don't typically have to go through as long of a use case to be able to identify where the problem is. Now, everybody doesn't adopt it though, so organizations are still struggling. It really amazes us at Parasoft. We've been talking about API testing for as long as I've been with the company, which is a little over 15 years now, and really organizations are still struggling. So when we talk to new clients, new partners, and trying to figure out what the challenges are, these are some of the typical initial kind of comments that we get. Typically, the test team doesn't know how the API is intended to be used. The development team may deliver an API, deliver a Swagger document, an open API document, and say, here you go, here's the APIs, everything's documented, great. But these are just a series of discrete data points. Trying to understand how these APIs communicate together to deliver some overall functionality is very challenging. And when you're thinking about it, a UI is very intuitive. I can figure out how a piece of functionality works through the UI because it's designed to be easily accessible. When I talk about the API, that's much harder to decompose. This leads us to believe that there really requires a specialized set of skills and tools needed to get the comprehensive test coverage. And because it's difficult for a tester to migrate from a UI-centric model to an API-centric model, and because, frankly, the developer feels that they've delivered everything that's needed in that Swagger document, API testing, or the validation of the API layer, tends to fall into this no man's land, where it's becoming kind of nobody's job. Development teams say, you got everything you need, and the testing team saying, we don't know how to use it. So what we're going to talk about today is how we can address that. And when we move into that, it's actually worthwhile thinking about what we talk about or what we mean when we're talking about an API test. And really, there are two types of API tests. There are tests where we are testing the individual component, or you can almost think of them like as a unit, the individual API. Maybe it's a small number of APIs working together. And then there's more of an integration test where I'm looking at the API, the entire API document, the entire Swagger, or the entire thing as a holistic strategy. And I'm looking and thinking about how all of these APIs work together, maybe across different sets of interfaces, maybe across different Swaggers or different WSDL documents, for example. So there are two approaches. The first is a top-down approach, where we're going to start and talk about, okay, how can we monitor how an application, front-end or a back-end system is able to use those APIs, how it uses those APIs to chain them into a sequence, how that represents the scenario. And then we're going to talk also about a bottom-up approach, where we're taking those description documents and how can we use those in the most effective way possible to start building out tests that test individual components, either an individual API or chaining API calls together to represent a small use case. So we're going to go through three things. I'm going to talk about the top approach, creation by monitoring usage. We're then going to talk about a bottom-up approach, creating but from the design documents, from the Swagger or the RAML OpenAPI or WSDL document. And then we're going to talk about how you can then understand what your coverage is, because ultimately the goal here is to ensure that I'm testing the application's functionality as completely as possible. And we're going to talk about three different ways of looking at coverage. So hopefully the 50% that didn't know how to answer the question or skip straight past it, can actually, we can give you answers to that. So with that being said, I'm going to now switch over to Chris. So let me stop sharing, Chris.
Thanks, Mark. All right, let me go ahead and share my screen. Everything looking good?
Yep, that's great.
All right, so let's go ahead and talk about the three approaches that Mark just mentioned. So to begin with, let's go ahead and talk about the top-down approach. This approach is where we create our API tests through usage. Now, the idea behind this approach is that we want to be able to understand how our APIs work, even if we don't have intimate knowledge of the documented or undocumented APIs, how they interact with each other. And a great way to do this is by leveraging record and playback. So I'm going to go ahead and do an example of how that would work in the Parasoft landscape. And I'm going to use my application here, Parabank. So Parabank has a front end, and that front end is communicating to front end services, RESTful services, via an HTTP transport. We can capture the interactions between the usage of my UI and look at the different API calls that are being made, string them together into a meaningful API test scenario. Now, I want to point out that I'm showing this from a front end, but really the practice is record traffic really from anywhere in the system as you interact with the system. And then in our particular case, we leverage AI to bring that traffic together into a meaningful scenario, looking at patterns and relationships. But we'll get into the AI piece in just a second. I'm actually going to go ahead and start an example here. So for Parasoft, we have the Parasoft Recorder. We first introduced the Parasoft Recorder last year when we introduced the Smart API Test Generator. It's been recently enhanced to record UI tests, building Selenium tests for Selenic. That's a later conversation. For now, I'm going to go ahead and just record the API traffic. I'm going to start my recording, and then I'm just going to interact with my system. And the idea would be, I have a particular use case, and I want to understand what the APIs are for that use case, but I don't exactly know how to grab those particular pieces out. So here, I've done a call here, gotten this accounts overview. I'm going to go ahead and just say, let's open a new account, and then I'll go back and review and make sure that that account was opened. Pretty simple usage, but there will be some interweaving of data payloads with those APIs. I'm going to go ahead and stop my recording. And from here, I'll get a panel that will say, OK, let's make an API test. I'm going to call this my accounts scenario. And I'm going to associate it with one of my stories here in Jira. And this will become important later when we start talking about requirements coverage. And I'll go ahead and create a test asset. And that'll take just a second, but then I will get a notification here of the asset being ready to be used. It looks like it popped up on the other screen here, so I'll go ahead and jump here into my API testing area. I'll go into my particular folder, users, ccolosimo, and here's my accounts creation scenario. Now, this is great because by simply using the application, I know what I did. I know that I logged in. I know that I checked accounts. I know that I created an account. And then I know that I checked that account again. And we can see here that the API calls that were made in the back end reflect that interaction. This makes it easy for me to then start understanding what calls are called in which particular sequences. But to make this truly meaningful, I need to be able to exchange data between these API calls, and this is where the AI comes in. You'll notice here that we have a series of smart tools. And the way that these smart tools work is that they have identified that there is data that needs to be transferred between the different calls. In this particular case, when I looked for an account, it said, hey, you know, that account actually looks like it shows up later. And the same thing with some of the text that was on that particular call. And then in subsequent calls, when I say potentially create an account and then go back and look at the account, it's seeing that the data is changing. And so by automatically parameterizing that, I can get an understanding of how my APIs interact with each other. Additionally, you'll see that we've actually started creating some smart assertions. And we're creating these assertions because we're seeing common data objects moving and changing. And so we can make the basic assumption, hey, this may be something you want to assert on. In this particular case, maybe it was the account ID, maybe it was the customer ID. And through this, I can start to get a really good understanding of what APIs are at play, both documented APIs that may exist in my Swagger doc, as well as undocumented APIs that development might have put into the application and I never knew about it. Okay, and so through this, you can create a nice top-down approach to creating those API tests. Now, I will point out that there's another strategy that we can use to actually extract these API calls out, and it may have to do with something that we already have existing. For example, our Selenium tests. So if you're an organization that's decided to use Selenium for your UI testing practice, you're going to be running these use cases all throughout your continuous testing practice. And these Selenium tests are a wealth of knowledge as to how the APIs may be working inside of the system. For Parasoft, we have the capability to extract out the API tests that are being made as we're interacting with as we're running our Selenium tests. Here inside of Eclipse, we have Parasoft Selenic, which is really designed at making Selenium easier by using AI to recommend locators and weight conditions. But an additional upshot of this is that we have the ability during our runtime to capture the API tests. And we can do that by simply connecting to our Parasoft SOA tests API engine and say, hey, let's go ahead and run this API test and grab those API calls, Selenium test and grab those API calls out. Now, again, there's many ways that you can interact with your system from a manual perspective, from simply interacting with it through your test automation, whether it's your Selenium tests. The bottom line is that these represent real use cases and real interactions that are validating real functionality in your application. And I believe this is one of the best ways to really get a nice inventory of API tests against the system, but more importantly, to help train yourself, what are those actual APIs that are being used? Can I associate that to the use case? Can I build my knowledge of this system? Okay, so you'll notice there I ran 3 Selenium tests, and all of that information was delivered back over here to SOA test. What I'm going to do is I'm going to go ahead and come back here and refresh my server so I can get those 3 tests. We'll just run this in the background, and we'll see here in a second. It's pulling in those test cases for us. And then as soon as that finishes refreshing, I will have brand new API tests. Should take just a second here. There we go. We'll go back into my little user area here, see Colosimo, and there we go. And so each one of those test cases is associated with the functionality that I just executed in the system. And the best part is, since we're leveraging the AI, you'll notice that a lot of that information has been stitched together from an API perspective. So these tests will be successful, and we'll be able to execute against the application with minimal configuration and give you a nice understanding of really what's happening in your API inventory as you're exercising your system. Okay, so I know a lot happened there, but in the top-down approach, there are multiple ways that we can create our API tests by usage. I showed 2 specific ones, interacting with the UI manually, and then using the SOA Test Smart API Test Generator to create API test scenarios that reflect how you interacted with the system. Good for exploring the different ways that the APIs are used in the system. Additionally, if you want to create some concrete use cases, you can leverage any of those Selenium tests that you have hanging around and execute them through essentially the same system to create those API test scenarios. And through that, we can build a library of API tests that model the usage of our application and really get a hold on what those APIs are. Okay, so this is one proven strategy from the top down. Another approach that you can take is from the bottom up. Now, you don't do these things separately, you do them together. And bringing them together allows you to create much higher levels of coverage across your APIs. I like to do the bottom-up approach after I've kind of done some exploratory investigation of my application, because now I know what those APIs are. And so when I go to actually start bringing those together in a unit type test, I'll be much more successful. So let me show you a demonstration of how we would create these from the bottom up. So I'm going to go back here into my API testing area. And let's say that my application had a service definition. With your applications, you have a RESTful specification with a Swagger or an Open API doc, or potentially a WSDL. we can leverage these documents to help us build every other API client that may exist in my API landscape. The good part, though, is since we've already sort of interacted with these through intelligent record and playback, we'll know how some of these APIs, what data is required to transfer to different calls, and how to make these scenarios more useful. And so I'm going to go ahead and simply create an API suite here in bulk using this Swagger doc and do just that thing. So I'll start here again in my browser-based dashboard. And I'm going to go ahead and say, let's create a new test scenario. Now, again, there's many ways that we can do that. We've talked about several of them. Here, I'm going to go ahead and do the Swagger doc, paste the Swagger doc in, and we'll call this API, Parabank API from Swagger, and save. It'll read the Swagger doc, parse the Swagger doc, and then give us every client for that Swagger. And here I could then go in a very granular way, create a series of tests where potentially I'm injecting the relevant data that I need to, maybe supplying the data that I know and have learned by my interactions with the system, and then executing those tests. But what I'd like to do actually is take a little more granular approach to this, execute these individually, but then also execute them as a part of a sequence. So to do that, I'm just going to jump down here into my desktop client. And so this is a SOA test desktop client. It, as you can see, it synchronizes those test cases from the browser client. And it makes it really easy to go back and forth between the browser and the desktop, depending upon the level of horsepower you want for your API testing. Here's the suite of tests I just created from that service definition. And so as we can see, I have all the test cases here. And I could come in and drive these with data or design different usage patterns for them. Here, I'm just going to go ahead and just do a single call to get accounts against my system. I'll go ahead and execute this. Let's see, I get a response back. The response is a nice object here that I can then go ahead and validate either by building an assertion directly against the payload that I'm seeing here, or a diff tool, or by stringing it together into a scenario. Now, I'll be more successful stringing these together into a scenario because I've already kind of understood what different objects are being passed. I have examples of those from the test cases that I created from my recordings. So what I'm going to do is I'm going to go ahead and just copy two clients here. I'm going to get account. I'm going to deposit some money into the account, and then I'm going to check my balance after I've deposited. So I'll go ahead and come in here and then add a new test suite. And there's many ways that we can create these tests, again, either by the traffic or the rest. But in this case, I'm just going to create an empty placeholder. I'm going to jump in here, and I'm going to call this my account scenario. I'll go ahead and paste in those two clients that I just copied. Get account, deposit information. And because I want to go ahead and check it at the end, I'll go ahead and paste that get accounts again, and I'll just call this get accounts too. Oh, it already added that for me. Great. Okay, so I have a little scenario here. I can go ahead and run this, and you can see here that there's really no scripting involved. I'm simply going through and applying in a visual way different clients to achieve the interaction that I want. Now you'll notice here that when I went to do my post, this guy highlighted red, and it's highlighting red and indicating to me, hey, there's something wrong with this particular request, the post. This post, as you can see, when I actually sent the information in, I sent 0, because this deposit doesn't actually know what account came back from this account's call. And so you can easily string these calls together by defining parameterization. And parameterization is a fancy way of saying, hey, I want to get data from previous tests and apply it to later tests. So in this case, I'll go ahead and say, let's grab something from the response here, from the response traffic. There's many things that we can do. We can get into a lot of this later if you're interested, but really we've designed it so that you can do many things with the solution without having to write a single line of code. Things like looping, test flow logic, data driving, even things like BDD or taking screenshots as you're interacting with your system. All can be done without scripting. I'll go ahead and grab that ID out, store it into a temporary variable, save. I can then go back into my test case and apply that variable right here. Now, I may want to deposit a random amount into the account, and I could either do that by defining a data source, a spreadsheet, a table, something like that, or I can do that by adding a random tool, a random number generator tool. So in this case, I'm going to go ahead and say, let's add my data repository, excuse me, my data generation tool, which allows me to generate data. Maybe I'll generate a random number, dollar amount, somewhere between $1 and $100. You can kind of see how this comes together to enable me to create a scenario. I'll go ahead and call this my ran val, save, apply, and then use those data values here inside of my test. Okay, so long and short of it is this allows me to create a series of clients both from the top down and from the bottom up, and from those achieve a couple of different things. Understanding of my APIs, understanding of how my APIs interact with each other, a broad library of test cases, and then test coverage, where I can understand what each one of my APIs is actually interacting with. And I can do this because I have access to that service definition. And that service definition governs all things. And so as I interact with those different APIs, I can understand what I have tests against, whether those tests are successful, or whether those tests are failing. Okay, and so top-down approach, creation by usage. Bottom-up approach is creation by design. But in addition, I want to be able to add coverage into my testing strategy. And so for that, I'm going to go ahead and hand back to Mark to talk to us a little bit about API coverage.
Cool, thank you, Chris. So when we talk about understanding what my coverage is from API testing, there are really three types of coverage that we want to be thinking about. The first is the coverage as it relates to my requirements, my features or my user stories. In essence, some traceability where I understand what I am testing, not just kind of a blanket number, but being able to trace that back to understanding what actual use cases have been validated. The second thing is being able to understand how much of the API I'm testing, because I could be testing all of my use cases, but there are some APIs in there which aren't actually being used. Again, this is actually, Chris already kind of showed us that with the API coverage report from SOATest. And then going deeper is to understand what parts of my code are actually tested as well. So understanding code coverage, because there may be some APIs that are undocumented. There may be some use cases inside of the code that haven't been exercised. So these three types of coverage together really give me a holistic view as to how well I am testing the functionality. Now, as I said, Chris already talked about API coverage. What we'll talk about now is actually looking at how we can get coverage for both the requirements and also the underlying code. So here what we've done is we've switched to our reporting and analytics dashboard where we're aggregating data from across my testing practices. So everything from code analysis through unit testing, through functional test automation with SOATest or Selenic, as well as actually results from manual testing activities as well. Now, if we switch our dashboard, we can actually go to looking at a dashboard which we've pre-configured for today to show us some of our functional testing results. We can see that I've got, against this project, 113 tests that are running. Looks like I've got about a 50% pass rate on the top left. You can see a trending. We can see I've actually only got 3 builds worth of data in this demo data set. And then as I move to the right-hand side, I can see the actual individual test suites that are running as well. Now, this gives me an overview of what testing I've done, but how good is that testing? What am I actually testing? And there are two parts of this dashboard that we're going to talk about. We're going to talk about the bit in the middle where we've got Jira stories, and we're going to talk about the coverage trend at the towards the bottom. We'll talk about the coverage numbers also. So let's start with the Jira stories here. So if you look on towards the right-hand side, here I've got a pie chart showing me how my coverage or what my testing status is against each of my stories that are inside of Jira. So for example, here we can see that 37 of my requirements, total number is 66, as is on the left, and 37 of those have been tested with a pass state. As I move around to the right-hand side, you can see 2 tests are incomplete, meaning that they didn't finish, they timed out or something like that. And then they've got 6 where actually tests against those 6 requirements are failing. And then lastly, I can see that I've actually got 22 requirements that have no tests in this scenario. So let's go ahead and drill in on all of those requirements. Let's drill in on the 66 and see the traceability report. Here I can see for each of those 66 requirements or stories that are in Jira, I can see their information about, okay, the summary of what that story is, as well as the test status. So if we drill into, for example, the second one on the list here, so customer may log in to Parabank application, I can see the details of which tests are touching that story. And this is all done by associating the test with a requirement inside of the test itself. We can actually drill down further. So if we just go ahead and let's go ahead and take that first one or the second one there on the list. You can see here there's a whole bunch of information about what that test failure is and what the purpose of it is, and I can actually drill down to the individual test itself and see what's going on there. Now, when we're doing this aggregation, as I said, we're correlating back up to the actual requirement. And we're able to look at seeing, okay, what's associated with this particular test. So here you see at the bottom here, associated artifact says requirement par 2. That's obviously coming from Jira. But I also know through Parasoft's proprietary coverage engine what code is being exercised as part of this test. So if I look at the coverage tab, I can see the specific parts of the code base that this individual test is exercising, giving me the ability to drill down. So for example, I could look at the first class here, the bookstore database, and you can see on the left-hand side, I immediately see what the code is going on in the code. And if I scroll down in here, you can see what parts of the code are actually being exercised. So let's go ahead and roll all the way back to the dashboard at the top. And so here, what I actually went is I went pretty deep. I actually started at a high level. I can see that I've got 66 requirements, of which 22 of those don't have coverage today. I can drill in and see what the details of each of them were, but I showed you how you could get all the way to the underlying code coverage. So let's actually take a slightly different view of that. Let's go ahead and you can see here in the trend, you can see what my coverage number is for my functional testing. And if I drill in on my coverage perspective, I can see the coverage as it relates to the code base. So if I expand out some of the parts of the code base here, and maybe I drill into the bookstore DB class, you can see what the coverage is for that individual class. I can also see at the bottom of the display here which tests are exercising that class. And again, if I click on the View All Tests link, it'll take me and show me each of those classes, and I can kind of start each of those tests and start interrogating those individually. So being able to aggregate all of this data together across my functional testing practices gives me the visibility to understand what my coverage from a requirements perspective is and my coverage from a code perspective. But furthermore, you can actually combine this with other types of coverage. So if I look here on a different dashboard, you'll see that what we've got in the reporting and analytics platform is we've aggregated coverage from across the testing of manual, functional, and unit tests, and getting an overall combined code coverage number of the underlying code base. Looking at these three numbers together, so looking at the requirements coverage or traceability, looking at the API coverage, and looking at the underlying code coverage, you can get a true understanding of how well you are testing the APIs, and also understand how well your APIs are contributing to the overall coverage of the application's code base. So let's go ahead and switch back to the PowerPoint. So we talked about aggregating the coverage from across the testing practices. I showed you that right there with the code coverage. Traceability also does that same aggregation, and aggregation back to the requirements or the work items, the user stories, is a critical component to ensure that you are testing the right thing. But there's something else you need to consider. As you do more testing, and certainly as you're doing more and more testing on the higher parts of the testing pyramid, you have to consider the amount of time that it takes you to test the application. You're looking for code coverage, but you really need to focus on getting, you're looking for coverage in general, but you need to focus on making sure that I'm getting coverage on the parts of the application or on the use cases that matter. And the biggest part of the highest priority should be to look at the things that have just changed. So this is where we can help with optimizing your test execution to get you quicker feedback and get focused coverage on the changes in the code base. Because we know code bases are complex. A change in one area can have an unexpected influence on a completely different part of the application. So again, through the use of Parasoft's proprietary coverage engine, we're able to understand what parts of the code base your testing activities are touching. So at an individual test level. I showed you that earlier in the dashboard when we were looking at those. We can then analyze what changes are happening in the application, either at the code level from the point of view of integration with the build process, or by analyzing the Java binary and understanding what's changed in the method signatures. By analyzing that, actually not just the message signature, I should say, it's actually the changes in the method at the binary level. By cross-correlating those changes with the coverage, I can then take my test suite and reduce it to only focus on those tests that need to be executed, providing me quicker feedback. Now, this is really important when I'm talking about CI/CD, and I want to get quicker feedback during those later stages. Often when organizations scale the test automation strategy, the test suite takes hours to respond because there's a lot of tests. You don't have 2 or 3 tests, you have 2 or 3,000 or 10 or 20,000. So for example, at Parasoft, we have to run our full comprehensive set of regression tests against our SOA test product actually takes over the weekend. It has that many tests. But what we want to do is to focus on getting quicker feedback as quickly as possible on the things that we're changing now, so we can provide feedback to the development team. Now, we introduced this to the market a couple of years ago through DTP, what I was showing you with the reporting and analytics dashboard. Last year, we actually took that further and introduced capability for Java unit testing with our JTest product to accelerate both unit tests within the developer's IDE, but also as part of the CI process. We've actually just released that with Parasoft SOA test for API testing, and Chris will actually be showing that to us in a second. And then we've also introduced that for Selenium tests with our Parasoft Selenium product as well. So let's go ahead and talk about how we do that for API testing specifically. If you'd like to know more information about the Java or the Selenium testing, we can kind of follow up on that. We actually have some online webinars and little recordings that show that already.
All right, so let's show how we can optimize our execution. So I'm just going to go back here into my system, SOA test. And so, yeah, I've been creating some tests. I have, what, 3, maybe 4 tests that we created during this. What I can do is I can take those test cases and I can execute them and gather coverage while I'm executing them. And the way that I would do that is run the test with a special test configuration. It's all built here into SOA test. In this case, I'm going to run it with a test configuration where I'm going to connect to my application that I'm currently instrumenting with a monitor. I'm simply starting it up with a special monitor. Connect directly to that application and then tell it to run the tests. It will automatically store the coverage data into a file. Okay. So, in this case, I executed 11 or so, but maybe I could execute hundreds of tests against the application. And then that coverage file can then be used to understand what the impacted tests are. Now, here I'm going to show this from the CI perspective because all of this can be run from the CI. The idea is that I don't need access to the code in this case. I simply need to point at the new WAR file. So if I can point at that new WAR file and then delta that against the coverage that I collected, it will give me a list of test cases that I need to validate the changes. Now, this is going to take a second, so I'm going to go ahead and execute it now. And so the idea is that when you had your code check-ins, you would analyze that new binary against the current coverage that you have for your API tests. And from that, you would get some information. So in this particular case, what it's doing is it's starting by reading the current coverage report that was created as we were executing our API tests. In this case, it said, hey, your application has about 609 classes. And now what it's going to do is it's going to go ahead and look at the new WAR file. And so this is really the exciting part because, again, it's just scanning that WAR file, the updated WAR file, and it's saying, okay, some things changed. And since we understand what tests are associated to the code, we know which tests we now need to rerun. The really cool part here is instead of just saying, hey, these are the tests that you need to rerun, SOATest will take it upon itself to automatically rerun those tests. And so here we saw that just happen. And so we have a subset of tests that executed. If we wait for SOATest to shut down here, it will go ahead and provide us a report back, and we'll understand exactly what happened. So in this case, in order to validate the changes between version 1 and version 2 of my application, I only needed to run this one test scenario. It had 5 test steps, and it was testing the bill pay functionality of my application. Apparently, that's the piece that changed, and I needed to validate it. And so through that, I can optimize my test execution and only run the subset of tests required to validate the changes. All right.
Cool. So, and actually something to point out there is what Chris just showed us is how you can automate the execution of SOATest as part of a command line execution. So note that he wasn't running in the IDE again. He was actually running as part of his command line process, and there would be that script would be embedded into a Jenkins pipeline. That was one of the questions that came up prior to the webinar. So I kind of wanted to make sure we touched upon that. Okay, so the thing is though that, as I said before, API testing is just one component of a scalable test automation strategy. And there are different techniques and technologies that we have available that plugs into the Parasoft Continuous Quality Suite. So I touched upon JTest earlier. JTest is our product for Java developers to help them create JUnit test cases in a completely vendor neutral way. Tests that are created with JTest can be fully portable and executed in any CI/CD pipeline. If you execute them with JTest, though, you then have access to the test impact analysis that we just talked about. JTest also has the ability to make sure that we're building our test automation practice, our pyramid, on solid ground with deep code analysis for reliability and security, going beyond what you would have with an open source technology or a technology like a SonarQube, for example. Where we focused our discussion today has been around API testing with SOATest. So the ability to be able to test both by design, so looking at the WSDL document and being able to interrogate a Swagger or an Open API or a RAML, decompose that into individual units that can be reused and seamlessly chained together is really, really critical and powerful. But the ability to be able to actually monitor how an API is being used and use that to understand how the API is used and create tests from that really is a super skill of SOATest. And just to kind of emphasize something Chris touched upon is while we've been doing this within the UI, one of the questions that came through in the chat is, but what about if my API is not being touched by the UI? And that would be a typical example in a multi-tiered system. We can monitor the traffic inside of the network by leveraging message proxy recorders or leveraging something like a Wireshark, and taking that same data and using it to create those tests using the Smart API Test Generator. Now, one of the things we didn't touch upon too much in today's webinar, but it was one of the questions as well, is like, how can I do performance testing of my APIs? SOA test can seamlessly, or SOA test artifacts can be seamlessly leveraged by a sister product, Load-Test. So here you can take a TST file, one of the artifacts that Chris just showed us, and seamlessly take that and execute it under load across multiple machines, across a cloud-based ecosystem. And the value here is that performance testing at the API level really is very, very scalable. You don't have to worry about browser interactions and scaling up individual machines. So it's a very computationally efficient way of doing early stage performance testing. However, when you do early stage performance testing, you are going to run into challenges with the constraints of your test environment, not being able to satisfy the performance characteristics, or not being available, not having the right data. These challenges can be addressed with service virtualization and Parasoft's virtualized product. This enables us to shift left the execution of those tests so you can use them earlier in the process, and really eliminate the external constraints and control the performance characteristics of the dependencies that you're using in the test environment. And then lastly, Parasoft Selenium. We talked about that earlier. This is our solution for helping Selenium testers with their Selenium testing practice. It does several things, addressing the challenges of maintainability and creation of Selenium test scripts. But what Chris showed us today is he showed us how we can leverage our Selenium scripts to create API tests. So there's integration between these technologies. Now we have a number of clients applying our technologies in different ways. Some of the advantages, obviously, we're talking about achieving greater test coverage today, especially from the point of view of those undocumented APIs that Chris mentioned. Reducing fatigue, simplifying test data. In essence, it's all about reducing the complexity and improving the efficiency of your test automation process. Now, if you want to learn some more, obviously, we'd be very happy to hear from you. Reach out to us at info@parasoft.com, but we also have some reading material that can hopefully help you navigate your API testing challenges. So we have a guide around choosing the right API testing solution, as well as a guide around how to choose service virtualization solution and the technology there. We also have a very active blog, which we'll probably bring up. In fact, actually, because that will be a good idea to bring up the blog as well and show where we have a lot of content under there. So, as I said, I've been monitoring the chat. I've answered a couple of the chats as we've been going through, but it's probably worthwhile to kind of just look at some of them, some of the other ones. So we talked about how we can automate. We talked about command line. Chris showed us actually that as part of the test impact analysis piece. Another question here, Chris, is like, what about microservices? And I think that's probably a good opportunity to talk about all the different ways, protocols, and what have you that SOA test has.
Yeah, great question. So I wanted to mention that. So in our demonstration, we were primarily dealing with XML, SOAP, REST, JSON, but really an API can be much more than that. We have asynchronous protocols that we're seeing emerge in microservices such as Kafka, RabbitMQ, things like GraphQL, which are different ways of querying APIs. SOA test actually supports over 150 message formats and protocols. It's kind of something we're quite proud of. In the SOA test portion of the Parasoft webpage, there is a text spec that would speak about all of the different types of message formats and protocols that are supported. And the same practices exist whether you're creating a basic REST JSON test, or if you're trying to isolate an individual microservice that's deployed over an asynchronous protocol. Inside of the tool, the design approach would allow you to build that client from scratch, put in the necessary message format and protocol, Define your payload, assert your response, and it really doesn't matter what technology is in play. And I should also mention that all of those also run under load. So anything that you create inside of the API testing platform, you can run as a part of your performance testing.
And essentially, a related question is around testing of SQL code. So we have a database tool inside of SOATest, which allows us to connect to SQL compliant databases, as well as we have actually additional tooling for NoSQL databases. Also a question around C++. So SOATest actually allows us to test any application from the point of view of a coding perspective. It's actually agnostic because it's working at the interface level. If you're talking about actually testing C++ code directly, I'd invite you to check out our C++ test product, very comparable to our JTest product that I mentioned earlier, designed to help with coding analysis as well as unit testing of C and C++ code. And it has a coverage engine embedded within it as well. So you can do exactly the same kind of coverage things that we were just talking about. Another question here is about best tools for learning and teaching PowerSoft SOATest. We actually, for customers, we actually have an LMS, a learning management system, available through our customer portal. It's available for free. It's included as part of folks' subscriptions. So you have access to that on our customer portal. And I don't know if you're able to look at that.
Yeah, I'm just going to throw that. I'm actually not showing this. I'm just going to throw this into the chat so that everybody has access to that.
Great. Two more questions, and I think that's probably it. One more question here is, I would like to send data to a gateway or a test management system. Okay, so DTP, the reporting and analytics platform, actually manages, it is our centralized quality hub. So it actually manages communications with other external systems of record. I showed you today kind of traceability, where we're actually pulling user stories, work items from Jira, and we're correlating the test artifacts. It also has the capability to send or push data to other external systems as well. We're actually about to release a new version of DTP that will have out-of-the-box integrations with Jira, including the X-Ray plugin for test management, as well as version 1 from CollabNet, Polarian, and Codebeamer, as well as others can be added through the use of our extension designer as well. So there's a lot of capabilities that are available there. If you'd like to know more information, please feel free to reach out to us. Okay, I think this is the last question. So the question is, may I know how to add the PowerSoft Recorder to Chrome? Do we have to, actually, let me not bother with the rest of the question. So yeah, how do we add PowerSoft Recorder for Chrome? Maybe we talk a little bit about Selenic as well as SOATest and how you get that.
Absolutely. So SOATest and Selenic are both available from our download site. In both of those solutions, you will have an executable that will install both the recorder and a recording proxy. Because as we mentioned before, it's not just about recording it from the Chrome browser. You may want to record that traffic from within your system, and so the different proxies will be advantageous in that. But yeah, you would go in through the product, and then the product would give you the ability to add that to your Chrome browser.
So a couple of other questions there, I think we kind of, I'm actually looking through the questions which were pre-submitted to make sure we covered everything, but I'm just gonna, I think we covered these, but I'm gonna touch upon them. There's one where I'm currently using Silk Test as a UI test automation tool. Any ideas how to, how to use Silk Test? So, the functionality that we talked about with Selenium today is actually not available for Silk Test yet, but I would actually want to kind of dig in a little bit further there, because certainly if you're using Silk Test, it may be that you're also using Selenium within the organization, and that might be an appropriate thing to kind of follow through on from that perspective. And then the other was talking about triggering automatic execution. Can we talk a little bit about the Jenkins plugins, Chris?
I sure can. Actually, I can show that actually if we want to see that. Let me just pull up Jenkins real quick here. The idea behind the Jenkins plugins, just let this load really quickly here, is that I want to be able to execute all of this as a part of my Jenkins process. And so Parasoft has built-in Jenkins build steps that are also available in Bamboo and Azure DevOps, TeamCity. But essentially, you can connect to the dashboard that you were seeing for the test scenarios and deploy an environment, which is a component of our service virtualization piece, or just directly execute a test scenario. Regardless, when you execute that test scenario, we will consume those results here back into the build process, thus allowing you to pass or fail the build based on success or failure of those test executions. And then all of this information will actually be reported all the way back into your requirements management system, as well as being able to take you right back to the environment where you had those test cases executing, as well as any live or virtual services that you had created.
Yeah, so execution of the test steps can be done, or the automation of the execution of the test can be done either through a command line where you're just executing the TST file, or it can actually make these build steps, this build step that Chris is showing you here, can actually be used to execute them when they're hosted within the ThinkFire platform. So there's a lot of flexibility there. Either way, you can consume the results back into Jenkins and you can dig down deep, as well as sending the data to DTP for historical analysis in combination with the other test data. Okay, very last thing we kind of just like to show you is our YouTube channel. So if you'd like to get some more information, we are hosting more and more YouTube videos. It's actually a focus for us at Parasoft to kind of enable folks to be able to consume kind of a lot of the content we're talking about today. There's actually a full playlist of actually talking about our entire functional testing solution. It's split into, I think it's almost a dozen different videos, all about 2 to 5 minutes long, kind of giving you an idea of everything end to end. Definitely invite you to check that out. It will touch upon absolutely everything and could give you a part of the conversation to help further with the team. Okay. There's one more question that came up. I'll follow up that one around using SOA test and JMeter together. We'll follow up that after today's session. It looks like you need us to talk to you later today, so that'll be fine. We'll follow up after this webinar. So at that point, we're at the hour. Thank you very much for your time today. We really appreciate it. Great questions as always. Please stay tuned to our channel. We're going to be doing another webinar in a couple of weeks. We're going to be talking about Parasoft Solanic. We're going to be doing that with one of the industry influencers, Joe Colantonio. And we'll be talking about the web UI testing challenges with Selenium. Chris and I will be both on that as well with Joe. And look forward to seeing you on that next webinar. Thanks very much. Have a great day.